Dear learners, we, Educational Multimedia Research Center, Madurai Kamaraj University, welcome you for the massive open online course on graph theory. The principal aim of this course is that students develop an understanding of the fundamentals of graph theory. Charlie Munger once said, "Mankind invented a system to cope with the fact that we are so intrinsically lousy at manipulating numbers. It is called the graph." Graph theory, a branch of mathematics concerned with the network of points connected by lines. The origin of graph theory is humble, even frivolous, says Norman L. Biggs. Yes, the origin of graph theory is humble, and the humble beginnings have led to grand success. The subject of graph theory had its beginnings in recreational math problems, but it has grown into a significant area of mathematical research with applications in chemistry, operations research, social sciences, and computer science. For example, Google's successful web search algorithms are based on the www graph, which contains all web pages as vertices and hyperlinks as edges. In other cases, as in social networks such as Facebook or Twitter, the sheer number of users of such services contributes to the huge size of the graphs representing a particular social medium. The history of graph theory may be specifically traced to 1735, when the Swiss mathematician Leonhard Euler solved the Königsberg bridge problem. The Königsberg bridge problem was an old puzzle concerning the possibility of finding a path over every one of 7 bridges that span a forked river flowing past an island, but without crossing any bridge twice. Euler argued that no such path exists. His proof involved only references to the physical arrangement of the bridges, but essentially he proved the first theorem in graph theory. The first unit contains 7 modules in which we introduce graphs and we discuss its elementary properties, and also some special graph structures. The topics covered in Unit 1 are Introduction to Graphs, Basic Properties of Graphs, Complete and Bipartite Graphs, Isomorphism of Graphs, Paths and Circuits, Eulerian Graphs, Hamiltonian Cycles. The second unit contains 6 modules in which we introduce some special classes of graphs and we discuss about 2 specific applications: matrix representation of graphs, caudal graphs, weighted graphs, matchings in graphs, Hall's marriage theorem and its application, the traveling salesman problem, and the Chinese postman problem. The third unit contains 8 modules in which we discuss about the algorithmic aspects of graph properties, distances in graphs, shortest path and Dijkstra's algorithm, Floyd-Warshall algorithm, Bellman-Ford algorithm, trees, spanning tree in graphs, minimum spanning tree algorithms, Kruskal's algorithm. The fourth unit contains 5 modules in which we discuss the concept of graphs like independency, planarity, and connectivity, independent sets and coverings in graphs, planar graphs, Euler's formula, cut vertices, and cut edges, edge connectivity of graphs. In this course, we have tried to cover the basic concepts of graph theory as extensively as possible for the students at an undergraduate level. We hope that this course will serve as an useful tool to any learner who wishes to know more about graphs.